but this is our last section in Unit 4. So here we have two formulas when we are looking at compounding interest. Our first formula is A equals P times 1 plus R over N to the NT. And that is if it compounds monthly, quarterly, weekly, anything like that. And our other formula is A equals PE to the RT. And that's if it compounds continuously. So P is the principal, that's your initial amount. R is the interest rate. N is your number of compound cycles per year. So if it says annually, that would be 1. If it says semi-annually, that would be 2. Monthly would be 12. Weekly would be 52. And then T is the time in years. So that's, and then A is the amount you have after that time has passed. So for all of these, my P is 16,400. My R, a rate of 10% means 0.10. You're going to turn that into a decimal. My T is 9 years. And then what changes for each of these is my N. So annually, N equals 1. So that would be 16,400, forgot the 4, times 1 plus 0.10 over 1 to the 1 times 9. And I'm going to put that whole thing in my calculator all at once. 16,400, 1 plus 0.1 over 1 to the 1 times 9. Now, a side note that if you have a TI-83, you're going to have to put this exponent in parentheses. Otherwise, you're not going to get the right answer. So that would be 38,670.34. Okay. Semi-annually would be twice a year. So that means that N equals 2. So then I have A equals 16,400, 1 plus 0.1 over 2 to the 2 times 9. And so in my calculator, I'm just going to press second enter. That's going to pull up my last thing. And I'm going to change this 1 to 2. Because now instead of compounding our money once a year, they're compounding it twice a year. So they're generating interest for me 2 times a year instead of 1 time a year. 39,468.56. Okay. So next is monthly. And for monthly, would help if I could spell. N equals 12 because there are 12 months a year. So we would have A equals 16,400, 1 plus 0.10 over 12 to the 12 times 9. Insert a 2. Insert a 2. 40,187.34. And then weekly, N equals 52 because there are 52 weeks in a year. So A equals 16,400, 1 plus 0.10 over 52, and then 52 times 9. So again, that second enter is my friend on this one because I don't have to redo the whole thing. So instead of 12, that's 52. And again, that's because there are 52 weeks in a year, and this says weekly. That means they're going to pay me interest once a week instead of once a month. $40,302.64. And then daily, n would be 365 since there are 365 days in a year. 1 plus 0.10 over 365 to the 365 times 9. Insert a 5, 36, insert a 5. So see how we get a little bit more money the more often we compound? Not a lot more, but I mean at the end, that's 40,000. At the end, we wind up making like almost $2,000 extra by compounding daily versus compounding only once a year. So the more often you compound, the more money you will have because they're paying you interest. So you're more often, so your balance is increasing more often, which means that you have more money to generate interest on. And then if they ask you continuously, you use this formula instead. Continuously. So for continuously, it would be 16,400 E to the 0.10 times 9. .10. 40,337, 49. Okay, so if you're good with these two formulas, then this problem is just calculator work. Okay, so for the next one, compounded weekly means I'm going to need this formula. And let's see what we know. How much would you need to deposit into an account now in order to have $3,000 at the end? So that means that my A value is 3,000 of 10 years. An account that gets 4.7% interest compounds weekly. So then I have 3,000 equals P times 1 plus 0.047 over 52 times to the 52 times 10. So I'm going to put all this in parentheses or in the calculator. 1 plus 0.047 divided by 52 to the 52 times 10. 1.59965. And then I'm going to just divide by that. So 3,000 divided by this. So that means right now you would have to put in $1,875.40. 75, not 45. And 40 cents. And so this next question is very similar, only it says compounds continuously. So that means we're going to use PE to the RT. You want to have $5,000 at the end of 10 years, and your rate is 2.7. So then that would be 5,000 equals P times E to the 0.027 times 10. So again, I'm going to put this in the calculator. e to the 0.027 times 10, 1.3099 So then to figure out what P is, I'm going to have to divide 5,000 by that. So 5,000 divided by, oops, that. So you'd have to put $3,816.90. And we're always rounding to 2 decimal places here because it's money. And that's how money works. Okay. All right. So first of all, I always look for this first. That way I know which formula I need. So compounded weekly is this one. An investment of $4,300 means that I initially put in $4,300. Okay, that was all kinds of a mess. To grow into $7,900. So $7,900 is how much I want to have at the end. An interest rate of 4.7 means R equals 0.047. Move the decimal point over twice to turn a percent into a decimal. And then compounded weekly means N equals 52. So we have 7,900 equals 4,300 times 1 plus 0.047 over 52 to the 52 times T. I'm going to figure out what this is. $1.0009. That was 3 zeros. Well, this looks a lot like some of those equations that we were solving last time. So I'm going to divide by this 4,300. So 1.8372. And now when your variable is in your exponent, you're going to have to turn this into a log. So this becomes log with base 1.0009 of 1.8372 equals 52t. Let's figure out what this is. You know what? I'm going to just do this. That. And then I'm going to divide that by 52. Round your answer to 2 decimal places. To 2 decimal places, that's still 13. So that means it'll take 13 years if you start with 4,300 and end at 7,900. 4.7% compounded weekly. And just like before, this next one is very similar, only we compound continuously. So that's A equals PE to the RT. And this one says, how long will it take for your money to double? So it doesn't give me a starting and an ending. So what I always like to do for these is I always like to pick my own. So let's just say that your starting amount was $500. Well, then your ending amount would be double that, which is $1,000, at a rate of 0.065. So we would have 1,000 equals 500e to the 0.065t. Now, since e is my base, I don't need to worry about doing anything there, so I'm going to divide both sides by 500 first, and I'm going to have 2 equals e to the 0.065t. Now, since this was doubled, this is always going to be 2. That's why I'm allowed to pretty much guess, because this, no matter what, would have always been 2, since this value is always half, this value is always double that value. That's just the way it's always going to work out. But if you're not comfortable with that, then you can just pick values. Okay, so this would be the log. To turn this into a log, it would be log with base e, which is the ln of 2 equals 0.065t. The ln of 2 and then we would divide that by 0.065. So 10.66 years. Okay. So if it takes 7 years for money to double, so again, let's say that my P was 500 and my A was 1,000, in an account compounded continuously, how many years will it take for the money to triple in the same account? Okay, so first of all, we need to know the rate, because they didn't give that to us. So let's say 1,000 equals 500e to the 7r. Divide both sides by 500. So 2 equals e to the 7r. And then again, we have the ln of 2 equals 7r. So the ln of 2, and then divided by 7. My rate was 0.099. Okay, so now I want to know how many years will it take for money to triple in that same account. So this time, if I was starting with 500, I would want to end with 1,500. Triple. And a rate of 0.099. So now I have 1,500 equals 500e to the 0.099t. Divide both sides by 500, and I hope it doesn't surprise you that this turns out to be 3. Since it's tripling, when it's doubling, that winds up being 2. When it's tripling, it winds up being 3. So then when we turn this into a log, it would be the ln of 3 equals 0.099t. So then t is the ln of 3 divided by 0.099, which I'm going to do in my calculator. The ln of 3 divided by that last thing that I had. So that means it'll take 11.09 years. Okay. I've always had a really weird, complicated way to find effective rate. So when I was watching Andy's lecture and I saw that he had this way to find effective rate. I was pretty excited about it, honestly, because it's way easier than what I used to do. So to find an effective rate in account of an account that earns 5%, that means my rate is 0.05. Compounded semi-annually, that means that N is 2. So this would be that my effective rate would be 1 plus 0.05 divided by 2 to the 2 minus 1. So I just take that and plug it in. 1 plus 0.05 to the 2, and then minus 1. Ooh, I forgot to divide it by 2. I was like, that's not right. 1 plus 0.05 divided by 2, better, to the 2, minus 1. 0.050625. 4 decimal points. So move this over twice. You have 5.0625. So that's the little bit of extra that you earn because you compound more often than annually. So then quarterly N would be 4, and you would say 1 plus 0.05 divided by 4 to the 4 minus 1. .050945. Move the decimal point over twice, and you have 5.0945. So then monthly N equals 12. 1 plus 0.12 over, no, 0.05 over 12 to the 12 minus 1. By 0.1162. Weekly N would be 52. And then daily N would be 365. I'm not going to do those two because you're going to do the exact same thing that you did here. What? Why will my meeting end in 5 minutes?
I was just going to say something. I saw that pop up.
Oh, that's annoying. So then we're going to have to end it and come back. And I'm going to have to do a second video, which is really stupid. So for compounding continuously, you would do the second formula, e to the r minus 1. So my rate here was 5. So this would be r equals e to the 0.05 minus 1. E to the... They were giving us 45 minutes, and now they're all of a sudden only giving us a half an hour. 0.05, 5.1271. So that formula, Vandy's, is pretty cool. I wish I would have known it because I always used to do this a little bit more annoyingly, where I'd be like, okay, plug in $1,000. How much do you have at the end of a year? What do you notice is the difference? And that worked. It was just stupid. All right, I'm going to end the meeting, come right back, and we're going to finish these notes. And I'm going to have to put up 2 videos for tonight. Sorry. I'll see you back in a minute.
I think you're muted.
Okay, so This is just PE to the RT. Thank you for pointing that out, by the way, because duh. This would just be PE to the RT. So P, my initial amount is 900, and my rate is 35%. So the 35 and the 900 we pull right from the equation. So this, just because it's bacteria in a dish and not money, doesn't change the fact that we are still PE to the RT. Okay? And so then to figure out how many bacteria the dish will contain after 4 hours, we're just going to plug in 4 for T. 0.35 times 4. So 900 E to the 0.35 times 4. Negative 35.35. So 34.49. So 36.50. Okay. So again, this formula is the exact same as the formula that we were using on the money problems, where it's the amount after time, the initial amount, the rate, and time. Okay, just because it's bacteria doesn't change what the formula does. All right. So the next one, in very small lettering, says the population of a city in 2010 was 4.9 million, and the relative growth rate was estimated at 2% per year. So then we're going to call that my initial population was 4.9 million, a growth rate of 0.02. Assuming that the city's population follows an exponential growth model, find the projected city population in 2026. So if we're starting in 2010 and going to 2026, then that means that we have had 16 years pass. And for a problem like this, we're going to continue to use that A equals PE to the RT. So A equals 4.9 E to the 0.02 times 16. 4.9 E, 0.02 times 16. So then we would have 3 decimal places, 6.748 million. Okay. A bacterial culture initially contains 2,000 bacteria and doubles every half an hour. Find the size of the bacterial culture after 60 minutes. Okay. We could absolutely do what we did before for doubling and find a rate. I feel like, though, if you double every half an hour and you're starting at 2,000, then you're going to double twice. And I don't even know that, we need a formula for that one. Right? Because this is after 30 minutes, so this is after 60 minutes. Now, that would obviously get a little more annoying for 4 hours. So if you have a bacteria like this that doubles, then you can use the exponential formula that we learned last class and say that your base is 2. So this would be 2,000 times 2 to the T, where T is half an hour. So this is your initial, this is your growth rate. So here it's doubling, and T is your time. So my question now is, how many half an hours are there in 4 hours? So in this case, T would be 8. Because it doubles 8 times over the course of 4 hours. Times 2 to the 8. If you don't want to do it that way, you could do what I did up here and just keep on doubling a bunch more times. You get the same answer. 2 to the 8. 512,000. The doubling time of bacterial population is 15 minutes. After 110 minutes, the bacterial population was 7,000. Okay, so I'm going to use that p times 2 to the t. And I'm going to say after 110 minutes, if it doubles every 15 minutes, then how many times has it doubled? 7.3, or let's do that in a fraction, that way it's precise, 22/3. So then it has doubled 7.3 times. We're on our way to an eighth double. So that's what we're going to use for our t. And we got that because it is this 110 divided by the total number of minutes divided by how many minutes it takes to double. And then my A value, call this A, is 7,000. So 7,000 equals P times 2 to the 22/3, or 110/15.
It's 70,000.
70,000, you're right, I'm missing a zero. There you go. So 2 to the 22/3, P times 161.27. So then my initial population would be 70,000 divided by that. So my initial population was 434. So then to figure out how many bacteria there are after 3 hours, well, if it doubles every 15 minutes, then in 3 hours, it has doubled 12 times. Right? 4 times per hour would be every 15 minutes. So then 434 times 2 to the 12. I can just hear my husband yelling at my daughter out there. Okay. Grows at a rate proportional to its size means that we're going to go back to P, A equals PE to the RT. So starting with 880 bacteria, grows at a rate proportional to its size. After 6 hours, that's my time, we end with 5,280. Ooh. Buddy, come here. Come here, buddy. What is her problem?
I'm over here. She's over here.
E to the 6R, because we need to know the rate in order to be able to express this as a function of time. So then I'm going to divide by 880. $52.80 divided by 880. That's 6. So then the ln of 6 equals 6R. So R is the ln of 6 divided by 6. .02. Oh, it doesn't say. not O2, 0.2986. We'll do 4 decimal places. So then that would mean that P of T equals 880 E to the 0.02, not O2. Why do I keep on putting an extra 0? 0.2986 T. And so then after 2 hours, we would just plug a 2 into this equation. So 880 E to the that times 2. 1,599. 15,099. Nope, 1,599. 0.066. After how many hours will the population reach 1,730 bacteria? E to the 0.2986 T. We've done a bunch of these now, so divide both sides by 880. To the 0.2986 T. So then the ln of 1.9659, 0.2986 T. So the ln of that, and then we're going to divide whatever we get there by 0.2986. Nope. Right now I have to do it by hand. The ln of 1.9659 divided by 0.2986. 2.264. A lot of these are like the same equations over and over and over again. So for half-life, we're going to use a super similar formula to the one I showed you before, only we're going to say A equals P times 1/2 to the T. When it's doubling, this is 2, and when it's half, when it's a half-life, it's 1/2. Okay. So if a sample contains 400 milligrams, so that's my initial amount, how many milligrams will remain after 4,000 years? So for my T, I need to know how many half-lives have happened. So that would be 4,000, the number of years that have passed, divided by how long one half-life takes. So then we're at 2.516 for T. So then here we have 400 times 1/2 to the 2.516. 400, 1/2 to the, that thing. So we would have 69.94 grams left. So that half-life means how long it takes for you to have only half a sample left. So meaning if we started with 400 milligrams, then after 1,590 years, you would have 200 milligrams. And after another 1,590 years, you would only have 100 milligram. So I hope that makes sense. Okay. And then last but not least, another half-life question. The half-life of palladium 100 is 4 days. After 16 days, a sample has been reduced to a mass of 5 milligrams. So we're going to use that same formula. We're going to say in this case that T is the 16 days that have passed divided by the 4-day half-life. So that means that this has been cut in half 4 times. And its ending amount was 5 milligrams. 1/2 to the 4. So 1/2 to the 4. And then do 5 divided by that. So that means that my initial amount was 80 milligrams. So then my new formula would be A equals 80 times 1/2 to the T. How many milligrams are left 6 weeks after the start? Okay, well, in 6 weeks, there are 42 days. One half-life is 4 days, 42 divided by 4. So that means we've had 10.5 half-lives pass. So then that would mean that I would have 80 times 1/2 to the 10.5. So I would have 0.055, 5 decimal places. 1, 2, 3, 4, 5, 2, 4. Milligrams left. So I think the only issue with this section is keeping all of the formulas straight. It's really 4 main ones. The A equals P times 1 plus R over N to the NT. The compounded continuously, which is A equals PE to the RT. The doubling times, the ones where it doubles, and that's A equals P times 2 to the T. And the half-life, which is A equals P times 1/2 to the T. I mean, I know that it's your test, but if it were me, even for my final, when I was doing the review, I might write down every formula that I use. That way I could have one central place where all of those formulas are so that you don't have to go searching for them since your final only has that 4-hour window. Just a suggestion. All right, does anybody have any questions? Okay, so I'm going to end again. That way I can process my second video. Then I'm going to try to figure out how to merge them. That way I don't have to put up 2 YouTube videos because that would be annoying. And I will see you guys back here in a minute.